What are square numbers or perfect squares? We have some numbers here: 1, 4, 9, 16, 64, 100, 144, 169. Now, this number 1 can be written as 1 raised to the power of 2, that is 1 times 1. This is 2 raised to the power of 2, that is 2 times 2. This is 3 raised to the power of 2, that is 3 times 3. 4 raised to the power of 2, that is 4 times 4. Then 8 to the power of 2, that is 8 times 8. 10 raised to the power of 2, that is 10 times 10. 12 raised to the power of 2, that is 12 times 12. And 13 raised to the power of 2, that is 13 times 13. Now all these numbers have one thing in common. They all have been written as the multiplication of an integer with itself 2 times. Right? This is 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on and so forth. That is, if you have a number m, and if that number m can be written as n raised to the power of 2, that is n times n, then that number m is a perfect square. Right? Perfect square. But wait, our discussion is still not over. Two questions should come to your mind. Is 0 a perfect square? And if this question comes, then another question will come to your mind, and that is, can we write this one as minus 1 times 1, minus 1 times minus 1? Because if you multiply two negative numbers, it will give the positive number only. Similarly, can we write this one as minus 2 times minus 2? This one as minus 3 times minus 3? And so on and so forth. So that means the next question is, can we write this m as n raised to the power of 2 also and minus n raised to the power of 2, right? And these two questions are really very important questions. Now, if you take 0 as a perfect square, like some mathematicians consider 0 as a perfect square. A perfect square. And why? Because they take it as 0. This is 0 raised to the power of 2, that is 0 times 0. Now, those who take this one as if they consider 0 as a perfect square, then for them actually even this one is also correct. That is, we can write 1 as minus 1 times minus 1. We can write 4 as minus 2 times minus 2, and so on and so forth. That is, for them this is also correct. This is also correct, and this is also correct. But some mathematicians, a few mathematicians, they think that this is actually wrong. They think that this is wrong. What they think is that this n should always be a positive integer. It should always be a positive integer. When you put this condition that this n should always be a positive integer, then there is no scope for 0. There is no scope of 0, because 0 is neither a positive integer nor a negative integer, right? So if you are putting the condition positive integer, then of course this one will also not get satisfied. You cannot take this one. So those mathematicians who believe that 0 and this condition is correct, for them this n can be any integer. For them this n can be any integer, right? So whether you consider this condition, that is, if you want to take as only positive integers, then that is correct. And those who take this one, the condition as n can be any integer, even those are correct. Those people are also correct. So it doesn't matter which one you follow, you will not face any problem, right? But in our course, we are going to take this, this one, that is, it should be positive integer. That is, if you write any number m as n raised to the power of 2, that is n times n, then this n should actually be positive integer only, right? So it doesn't matter whether you follow this one or this one, you'll not face any problem. And second thing, that this m will always be positive. This m will always be positive, right? Because 1 times 1 will give you 1, minus 1 times minus 1 will give you 1. So tell me whether minus 9 is a perfect square. Minus 9, you can write it as minus 3 times 3. Now, some of you can say that, hey, yes, this is a perfect square because we have 3. No, minus 3 is a different integer, 3 is a different integer. Even if you are taking this one, condition that it can be any integer, even in that case, these two are not the same integer. These two are not the same integers. That is, this is minus 3 and this is 3. Similarly, minus 144 is not a perfect square. You cannot say that, since we can write it as minus 12 times 12, therefore this is a perfect square or a square number. No, these two integers are different. Integers have to be equal, have to be the same, even their signs also.